In this video, we'll be learning about geometric mean and how to use the geometric mean to solve for altitudes and legs of similar right triangles. So your geometric mean between two numbers is the square root of their product. Pretend you have two numbers a and b. The mean of a and b is the number x in the proportion a over x equals x over b. When cross multiplied gives x squared equals ab. So x would be the square root of ab. So all you have to remember is you multiply and take the square root. So here the geometric mean of 45 and 5 would be 45 times 5 square rooted, or 225 square rooted. And we're going to solve for that. So I'm going to break this down into its factor tree. I'm going to search for pairs. Here I have a pair of 3s and a pair of 5s. There's nothing left over, so my answer is just going to be 15. The mean of 6 and 24 would be 6 times 24 square rooted, or square root of 144. Here we knew it was 6 and 24. 6 is 2 and 3. 24 would be 2 and 12, which is 2 and 6, and 2 and 3. So here we have a pair of 2s, another pair of 2s, and we actually also have a pair of 3s. So this would be 12, which you would have known because square root of 144 is 12. Now your altitude theorem tells you that the altitude of a right triangle, which is the length from the hypotenuse to the 90-degree angle, is equal to the geometric mean of the two segments of the hypotenuse. Basically, you take the two segments of the hypotenuse and multiply them and then square root it. So this piece times this piece square rooted. So here x is our altitude. You always want to check because this only works if it's an altitude. So we're going to do h1 times h2 square rooted. Or 9 times 6 square rooted. 9 is 3 and 3. 6 is 3 and 2. So here I have a pair of 3s with a 3 and 2 left over. So it would be 3 square root of 6. On this next one, we're solving for x, which is the altitude. So I'm going to multiply the two hypotenuse segments and square root it. So I'm going to do 8 times 5 square rooted. 8 would be 2 and 4, and 4 is 2 and 2. So this comes out to 2, and there's a 2 and a 5 left over, or 2 root 10. This is the altitude theorem. Again, it only works when x is the altitude. Next, we're going to learn about the leg theorem. This works when x is a leg. And what you do is you take the piece of the hypotenuse that's touching the leg, so here it would be h1, and you multiply it times the whole hypotenuse, h1 plus h2. Then you square root it. In this next picture, x is also a leg, but this one's closer to h2. So you would do h2 times the whole hypotenuse, which is h1 plus h2, square rooted. So when you're finding a leg, you instead of multiplying the two segments of the hypotenuse, you do the one that's touching the leg times the whole hypotenuse. So here, x is a leg. It's touching piece 9. And I'm going to multiply that times the whole hypotenuse. 11 plus 9 is 20. and I'm going to square root it. So this is going to be square root of 180. Now I'm going to look for my pairs. I have a pair of 3s, a pair of 2s, and a 5 left over. So my answer is going to be 6 root 5. On this next one, x is also a leg. So these are my 2 segments. So I'm going to multiply it times the piece that's touching it. So here it would be h1. We don't know h1. This whole piece is 8. This little piece is 2, so h1 would be 6. So we're going to do h1 times the whole hypotenuse, square rooted. So 6 times 8 square rooted. Now we can look for pairs. So I have a pair of 2s, another pair of 2s, and a 3 left over. So my answer is 4 root 3. So just to summarize, when you're finding the altitude, which is from the 90 to the hypotenuse, you multiply the 2 segments of the hypotenuse and square root them. When you're finding the leg, you multiply the piece of the hypotenuse that's touching the leg times the whole hypotenuse and square root it. Here we have some challenge problems. It's kind of like mixed review. So here in problem 1, I notice x is a leg. So I'm going to use the leg theorem, which means I need the piece that's touching the leg, this piece right here. 12 minus 3 would be 9. So I'm going to do 9 times the whole hypotenuse, which is 12 square rooted. Nine times 12 is going to be 108. Here I have a pair of 3s, a pair of 2s, and a 3 left over. So my answer is 6 square root of 3. On this next one, here they actually gave us the altitude. And they want us to find one of the segments of the hypotenuse. So here we're going to work backwards. So the altitude is equal to h1 times h2 square rooted. We know the altitude's h. We don't know h1. We have x. And h2 is 10. So here we're actually solving for x. The opposite of squaring would be to square root. Or sorry, the opposite of square root would actually be to square it. So we get 64 equals x times 10. The opposite of multiplying 10 would be to divide 10. I put a 10. I don't know why I did that. So this should be a 16. So it should be x times 16. And then the opposite of multiplying 16 would be to divide 16. 64 divided by 16 is actually 4. So here in this picture, x is equal to 4. If you were to do 4 times 16 and square root it, you would get 8.